Okay, so this is happening. I am still setting up. I'm going to. I haven't dropped the link on Twitter. I have. I only have like 700 something people on YouTube, so odds of somebody tuning in right away pretty low. So let me just go onto Twitter, and I'm gonna go ahead and drop this link, and then I have to drop a link to a friend who doesn't have Twitter, and then we'll get rock and rolling. And I can tell you about how ridiculous things have been so far. I was going to go about explaining like what's on the screen, but per what I just said, there's nobody here yet. So anybody watching this after the fact, if I do decide to like leave this up, which is 50-50, you'll just have to wait a hot minute until anybody comes in here so I can explain this jank ass setup. Okay, there will be a boring minute for a second while I send out invites because I don't have my social streaming stuff set up very well. Hold up one second. Amazing. I was able to remember my Twitter password. When is the last time that happened? Okay, now let's see if I can actually find this video in YouTube. I have never, ever done this before. And I know you can't see my screen, and that is what it is. You know, this says theoretically it's going, and yet I don't see it in my YouTube management page. This is going swimmingly. This is going, right? Right. It would be very nice to be able to share. There it is. Okay, it's finally up. Almost like half past already, but whatever. Good enough. Let's get a shareable link. Let's post that on Twitter. I wonder if I've gotten a single extra Twitter follower from my friends that I said, hey, I might be doing this tonight too. Probably not. I never use web Twitter, and that is what I'm on right now, and it is confusing. Profile, there we go. It's right there. Yep, 18 followers, no change. That's fine. That's fine. There is one view. I guess I could pop this open in YouTube. And this might sound really weird for you for a second. Let me try and mute the video as fast as I can. Let's see if there is one watching now. Amazing. Amazing. Cool. All right, I guess that means I should like start doing some stuff then. I might still give it a hot second. Oh, and I have to send that link to my friend, which is, I mean, anybody who's watching this, big possibility you know who I am and know my friends. And so therefore, I will just say it is Gentry, who is now living in Los Angeles, and I have to share this with, because he's actually going to watch, which is, it might just be him and whoever random person is watching on YouTube. I can't do two things at a time. Oh my God, it's him. How? Oh, you figured it out. Pretty good. Okay. Well then, I guess I have an audience of one, and that's pretty great. This has been an absolute cluster. There are a couple other people who said they might pop on, which, you know, the likelihood of that is questionable at best. But who knows? Or maybe I should just assume that I'm going to be re-explaining things several times. So for your benefit, I'll go ahead and tell you what the heck I'm even doing tonight. So there's a whole thing. Firstly, you can see, let's, because OBS is the coolest thing. If you have never messed with OBS, and I'm sure you haven't because you would not have a reason to mess with OBS, it's the streaming software everybody uses, and it is super, super duper cool. Costs $0, and like you can do this stuff. So you know this room. You've seen this room. And there's your pedal board. So that's fun. I would go to desktop capture so you can see my cursor, but you're just going to have to... Wait, no. I'm really dumb. That's the whole point of this thing. Because I got multiple cameras, which is super cool, and a lot of investment for no discernible reason. Okay, so it was supposed to be, I was going to use this Dell computer here as like the crux of this whole thing, but the idea is I've got the FirePod, the Fire Studio, whatever, it's a FirePod. And this is actually supported in Linux. And I wanted to play with Linux audio programming because, like, I've never done audio programming. Like, obviously, like every operating system in the world has audio stuff. I mean, that's like how, like, a Cubase or a, you know, you don't have to. You could just write software for the operating system's audio hardware instead of like going through a DAW or whatever. So I wanted to play with that, which I haven't done to this point. So the idea was, and presumably you haven't seen the other crap that I've talked about or streamed about, but I started screwing with this, and let me see if I can get this semi-working, actually. I kind of got a proof of concept working, but the idea that I want to do here, or the thing I want to play with ultimately is, since I have 8 channels on here, and it's just me down in my basement doing music things, I want to make this into like the world's most over-engineered looping station, so that I could like have 8 different instruments and like feed it through the mixer and all of that good kind of stuff. So the first thing is just getting 8 tracks of looping out of this thing. And I guess I can go back over there and show you. I'm going to be remote logging into there and doing some code crap, is the idea. And let me see if I can get what I had working. I think I'm logged into that laptop right now. That should be what this is. No, that's just this computer. And this was a whole thing, like I didn't have, SSH is how you remote log into a Linux computer or a Unix system of any sort. And like it just wasn't installed on my laptop over there. I don't know. The one good thing is, I didn't explain. So part of the cluster is that I was going to use that Dell box, and I had actually like set it all up. I installed Linux on it. So that could be like the machine to be used for this whole thing, and it could be like dedicated. And it just won't boot up today. So we're using the laptop instead, which is kind of fine because this is what I started messing with this whole thing on. So like the code should be on here. So if I do cd, where do I even have it? Code. Jack Foolin', that's what it is. Jack Foolin'. Because that probably sounds insane, but Jack is the Linux audio system. It's one of the Linux audio systems. It's the one that they use generally for like high quality studio stuff. It's supposed to be super low latency. and it stands for the Jack Audio Connection Kit. So it's a self-recursive acronym, which you will find a lot in Linux and Unix crap. But so that's what Jack is. That's why it's called Jack Foolin'. So there's two things going on as far as implementing this thing. There's Jack, obviously, and like the libraries for interacting with that, which is like the code that exists, so that you don't like have to do all of the common stuff. They've like already written the stuff that you need to do every time, like opening an audio channel and stuff like that, so that you can interact with the whole system. And then I'm writing it in a language called Rust for fun, which is kind of stupid, but it does have bindings for this library, which means, you know, it's exactly what it sounds like. It's the libraries are written in C, but Rust has good C support, and that's what a binding is it lets you use a library for another language in a different language. So let me look at the actual source, and we can actually look at what we have, and I can see if I can get this running again. All right, so here's a bunch of crazy code. It's actually deceptively simple. I mean, if you know how to program, I guess. Otherwise, just feel free to zone out and be like, that looks cool, and we'll see if we can make some sounds happen. So firstly, I just need to open this to remember where the heck I was at the last time I was working. And the last time I was working was I just had, or no, that's not true. So I had originally gotten just one channel working, doing anything. And if we run through this, basically client options are like the configuration options for the library and how to connect to the sound system. And yeah, so like this is stuff like this sets up the options. Jack Foolin' is the name of the application. And then Fool Process Handler is this thing that's like the core of my code that actually does the processing. I'm just trying to remember what everything is, honestly. This part like starts it, but the most important thing is what we had was this was sitting in a loop. Like after this whole block of everything just sets everything up. You know, tells the system, hey, I want to open this many channels. Let's start processing audio. This bit is when you run it, this line reads a line from the command line, and then this is a whole bunch of craziness. This is just setting a Boolean, or this is getting the Boolean. So there's a thing called effect on. That's literally just a Boolean value, but this is multi-threaded, which makes things real complicated, especially in Rust, because the whole deal with Rust is that it's supposed to be it's memory safe, like strictly. And what that means is like, so if you're programming in C or something, you can do anything to the system. You can just corrupt memory, you know, like if you have some data and you throw it in memory and you need to hang on to that. And like, let's say you have two threads. So you have like two, if you don't know programming stuff, it's like having two programs running at the same time, except it's inside the same program, and but it's two threads of execution. So you might have one over here, like processing audio, and one over here, processing user input, which is exactly what we have going on here. So this is a common thing that might happen in C, is like, this is messing with some data in memory, you know, it's like reading the audio out of memory in like a shared area. And this is like, let's say this is putting audio in there and this is getting audio back. Then all of a sudden this like writes to a slightly wrong area, screws up all of that memory. And now this reads it wrong, screws up everything it's doing, and you have a big old crash. That's a general like idea of what a memory safety issue is. And so that's obviously, it's a big issue in programming because you have, you know, this is what like a lot of, I mean, this is like the basis of most like viruses or security penetration stuff is causing the program to screw up in such a way that you can gain access to stuff or whatever. Like that's very particular and a very particular use case of the more general idea of exploiting memory unsafe stuff Ideally, your code would be written in such a way that like that's not possible, but people are so prone to errors, and it's just not reasonable. So this is the whole idea of Rust, and it's why multi-threaded stuff is real difficult. Is that the way Rust is built, like the syntax of the language, makes it impossible in theory to make any of those kind of situations happen, which is this big hole. I don't know Rust that well, but that's kind of why I wanted to screw with Rust. Is it's like, I mean, it's not new anymore. It's been quite a few years since it's out, but it's this new hotness of supposed to supplant C and C++ for systems programming and make everything completely safe. But so that's all this ugliness. And I'm sorry. I see there is Levko Kravt. I am so sorry. I don't do this. Kravitz is waving at me. So I'm going to go ahead and wave back because that's cool, because I is that one of my subscribers? Presumably. Let me actually go look at the YouTube side of things. I do not know. It would be so cool. I'm sure there's a way in OBS, because I'm just running this from OBS, to like see how many people and who is watching the stream, but I cannot, or I'm too dumb to know. So I'm going to go back to my studio. And again, sorry, you can't see my screen. You can't see my super secret stuff. Oh, there's the YouTube link. Let me mute it so it doesn't sound. Just running this from 3 watching. My God. Anyway, thank you, Levko. I assume I don't know you personally. And if that is not true, then I apologize deeply. Okay, so I had started explaining for Gentry, and I don't know when the other 2 people started falling in. But the whole idea of tonight is I've got, if you look over there in the upper right-hand corner, that's my horrible, horrible home studio. And if you look in the lower right-hand corner, there's the gray box. That's a Dell computer that I was going to use for this today, and it's broke. So next to that is the laptop that I'm going to remote into. That's actually what the screen we're looking at is, me logged into that laptop to write some codes. And it's to write some codes to run the box that's sitting on top of the Dell computer, which is 8 input, 8 output. It is technically 10, but let's just call it 8 for now, because I'm not going to use 2 of them. Anyway, I do music stuff, and I want to just play with this thing and play with Linux audio programming, and that's why the Rust and all of this stuff in the left-hand side here. But so we're writing code on the laptop to run that thing, and I was just running over the code and being a terrible describer of things. But I was describing all of this stuff just now that we're done with the Linux rant, and I'm just gonna press on with doing what I'm shooting to do. This sets up all of the Jack audio, the Jack Linux audio client software crap, and gets it going. And then that runs in a separate thread, and we'll go over look at that in a second. Then now we're back over here, and the whole Rust thing was me telling why this is even a thing, but this effect on thing is basically just a Boolean that's 1 or a 0, and it gets set here in this loop, which just sits here, waits for user input. Basically, you can type anything, but basically so that when you hit enter, this line finishes, and then it basically loads what was the previous value of effect on val through all of this crap, because we're multi-threaded and it's being super safe. And then stores, exclamation point means the opposite of that. So it takes what the value was and basically toggles it on off. If it was on, it goes off. If it was off, it goes on. And that's all that happens in this loop. It just sits there and does that. Then there's all this garbage up here. Like I was saying, the main chunk of code that does stuff is this fool process handler thing here, and that is all of that is most of this stuff up here. And again, this is having me help remember exactly what the heck I was doing here. There's a bunch of stuff up here that's just like stuff you need to do for Jack, because Jack sends you messages to say like, it's Rust. Wow, people are flooding in. Cool. There's a good handful in here now. That's impressive to me. Thank you very much. This is Rust for fun. I'm not good at Rust. It's going to be terrible. But so Jack, when like an audio device appears or you get disconnected from it or whatnot, stuff changes. It sends you messages, and I'm doing nothing with them right now because I really don't care at the moment. Then, okay, so this is the definition of what a full process handler is. Rust is funky in that like all of your code, it's funky compared to like a C++ if you have ever done C++ stuff or most other object-oriented stuff, because like you define basically what your structure looks like, which is structure for non-programming people is it's just how some stuff is laid out in memory. So you might have like it's like an object if you've done object-oriented programming, but if you haven't, you might have in memory like you want to know information about a person. Like that's what your program does. It manages people, and you need to know like their name and their age. And so you might have in memory a person is like a string name and some age. And so that's the structure in memory, that like a person will always be those things. So you might have several people in memory. Anyway, so that's what this is. It says a full process handler is basically a chunk of stuff in memory that has channels, which is functionally a list of these full loop channels, which is itself another structure. And that's one of the core parts of this whole thing. And then effect on. This is where effect on comes on. This is the switch that is turning things on or off, which we'll see as I get into this. Like I said, I'm looking to make a looper here, so like effect on doesn't really make a lot of sense here, and we'll probably be changing. We'll see if by the end of the night I even get past just getting this thing to start up and doing the stuff it was before. So channels are made out of full loop channels, which is the next structure down here. And a full loop channel has an import and an outport, which is the really simple thing that Jack gives you for it's a plugging in to, it's a port for audio going in or a port for audio coming out. And so a loop channel is just, it takes some audio in, and then, presumably when I get to like making this work, loops it, and then it will chuck that audio back out so that you can send it back out another port on the audio interface and hear it would be the idea. Kind of a crazy concept, but each channel has a reference to the effect on thing. I have made this playback buff. I remember kind of doing that when I was last screwing with this. This is a list of 32-bit floating point numbers. And I'm not using this for anything yet, but this will ideally be the thing that holds the stuff being looped. So for more music people, if Gentry is still watching, that's like it's like your tape. It's going to be like your tape in a tape looper. As it records, it's going to record into this, and it's just going to keep sticking 32-bit floating point samples of audio into here, and then we'll be going back through and reading them, and that's like the playhead. I'm not doing anything with that yet. I just remember I stuck that in for later, which is why I also have play position, which is where in this list are we currently playing from. Record position, which is where are we recording to if we're recording into the loop. And then record length, which is how much have we recorded so far. Not doing anything with any of those so far, because, like I said, I was screwing with this weeks ago and started putting in some of the looping stuff, but doesn't really do anything yet. So then in Rust, like I was saying, it has the structure in C++ or other object-oriented languages. You usually have like the code that operates on a type of data or a structure like this with the thing, and that's called an object. They don't really have that in Rust, even though effectively you can do the same stuff. So you have implementations of things. I'm going to try and not get off into the weeds too much. I've already gotten so far off into the weeds, but this is the stuff that does stuff with that data. This is a function that makes a new... I'm in Vim, and I just screwed things up badly. Let me go back to where I was. This is going to be an interesting experience, you guys. So this is just a function that makes a new full process handler, which literally just makes the effect on thread safe Boolean for everything else to check whether the effect is on or not. And then this is a bunch of really gross looking syntax that just does for 0 to the number of channels that we want to create, which is an argument to this, I think. Yeah. So like if I want 8 channels because this audio interface has 8 channels, that would be the idea. Is I just plug 8 in there and it makes 8 channels, and for each of them it makes a new full loop channel, which is the thing that has the port that it's connected to, whether the effect is on, all that stuff that we were just looking at. And it just makes one of those, and then collect just takes and makes that back into a list. So channels was one of the fields in that structure, right? So channels. So all this function does is you pass it all of this, the jack stuff, the actual jack audio system thing from Linux, and say I want this many channels, and it creates those channels and hooks them up to jack, is the idea. And then we have some code for dealing with full loop channels themselves, which is really the guts of this whole thing, because each channel manages its own reading audio data from Linux and processing it and writing it back out. And when these are created, they do some jack stuff. These are just a couple of functions that tell jack, hey, I have an input port, I have an output port, here they are. Sets up that playback buff, which again is just a big chunk of memory that I'm not doing anything with. I am assuming the sample rate is 44.1 kilohertz. Jack will tell you what the current sample rate is. Like, you don't control that because it's the system-wide sample rate in Linux, or at least that the sample rate that Jack is using. So if you don't, this is an interesting string because I'm doing. There's audio stuff that audio people will know, and there's programming stuff that programming people will know, and I don't know which audience to talk to first. But your sample rate is how many times the computer is looking at the incoming signal on a, you plug your guitar in or whatever, the guitar is making a wave when you play it, and then it's sampling it every so often to get a digital, how loud was it at this particular time, to reconstruct. That's what digital audio is. So your sample rate is how fast you're doing that. 44.1 is pretty common. I'm just making that assumption right now. Again, as far as I know in this code, I'm not doing anything with this playback buffer yet. So this is just some placeholder code that's saying, again, I'm not very good at Rust. If I recall, it's just saying make a vector, which is a list of things. It's going to be full of zeros and give me 60 times 44,100 zeros, which, if our sample rate was 44.1, which again is an assumption, and I will probably have to write some more code later on to actually say, hey, Jack, what's the current sample rate, and then deal with that. But whatever, we're just going to ignore that for now. Would give me 60 seconds of audio, because this is 44.1 thousand. It's 44,100 samples per second. Multiply it by 60. That's 60 seconds worth of samples. So that's why that. Anyway, it just fills out all of these fields. We're at playback position 0, record position 0, record length 0. That creates a given channel of processing. Then we have this function called process, which Jack calls. It's part of the whole registration thing. This process function, Jack calls when it's ready to have you process some data. So, Jack will be reading and sampling from the input ports on the audio capture device, and then, every so many fractions of a second, or however often it deems, it wants to give you audio, it'll basically call this function and give you a bucket of all of the samples that it's gotten up to this point. So it'll read for, it depends on how you set this up. This is if you've ever heard of latency in digital audio recording, this is one of the things that affects latency, because it'll record for so long, then toss audio over to the system for processing, and then start recording another chunk. And it does that for various reasons, but that's how you can control elsewhere in the system how long it's going to take before it chucks some audio your way. Usually fractions of a second, it's milliseconds. So we'll get hundreds, thousands of floating point samples every time this function gets called. But then that's the core of how all audio processing works digitally. Doesn't matter if you're using Jack or what. The idea is it's going to give you a bucket of samples that we've done up to this point. Then you can do whatever you want to them, and then send them wherever you want. So This is where the code continues. I was going to say starts to get hairy. It's all hairy. It's hairy. It's hairy. And if you don't know code, then it's just an absolute cluster here. So I've got a bunch going on here. Like I said, there's stuff for the looping that I actually want to do here, but up to this point, I just had it doing a very simple guitar effect just to make sure I could do it. So ideally, this process function would get that bucket of information and then toss it over into that, what on earth did I call it? The playback buff that I was just talking way too at length about. If you were recording into the loop, and otherwise we would take stuff out of the playback loop and put it in the bucket that's going to go back to Linux to send it on the output port to your speakers or whatever. Boy, I just got myself real lost. But this is just doing like a basic guitar effect. It's not going to do that stuff. It's just taking some stuff in, transforming the numbers, and then shoving them out another port. So this dry wet variable is, it's literally the ratio between the affected signal and the normal signal, and how to mix them together. Fun fact, if you've never done audio stuff or digital audio stuff, mixing is literally just adding two numbers together. So like if you have two audio streams, let's say you have a mixer, like you're at a concert and you have the mixing desk, and you plug two instruments or whatever into there and you mix them together and they come out the other side, you're just summing. It's literally just adding the volumes of the two things together. That's all mixing is. And then you have your faders and whatnot, and that's just bringing the respective volumes of them up or down before you add them. But that's cool because when you're doing digital audio, that's so easy because if you have two buckets of numbers, you just take the first bucket of numbers, add them to the second bucket of numbers, you get your third bucket of numbers is your mixed signal. And some of audio programming is really simple like that. Some of it is really insanely hard. Maybe I should come back to these. So dry wet is we're going to take the dry signal, which is the incoming signal that nothing has happened to, so it just sounds normal, and what's called the wet signal, which is an affected signal, so like distortion or whatever your effect might be, is called the wet signal. And what this is going to do is it's going to say, give me, when you mix them together, the dry signal should be at 20% volume and the wet signal should be at 75% volume, and then you add them together and it'll ideally sum to 100% volume, but it's just the relative ratios of how much of each of the signals you want mixed together, like a fader on a mixer or whatnot. Oh Lord, and Brandy's in here and she's just going, what the hell is going on? Feel free to dive out at any point. I'm writing audio software. I don't know when you started streaming, but here's some code. Hopefully it will evolve from code in a second. I'm describing my code way too much. What's going on here is then, oh God, and the point here is that also I'm reading my own code to remember what I was doing before. Okay. So if we skip a bunch of this for a second, this is really everything that's going on. If the effect was on, remember if I had hit the enter key and it toggled effect is on or not. This is again a bunch of weird, gross Rust stuff. But if it's on, then for each item in the bucket they gave us, which is called outslice, I'll get back to that. So we take the bucket that Linux gave to us of audio, and we are going to transform every single sample, do something to them, and that's what this does. We've just got two different ones here. If the effect is on, we use oct lambda. If not, we use dry lambda. This gets into some crazy computer science stuff. It's not that crazy if you do programming, whatnot, but it is crazy if you don't know programming stuff, because you're like, even in the first place, what the hell is a function? A function is, if you remember any math stuff, you can think of it math-wise like a math function. It takes a number in, does something to it, spits out another number. You can think of these ones like this. Oct lambda is a lambda is a type of function. We'll just call it a function that takes in each of these numbers, each of these 32-bit numbers, which is a sample of audio and time, and does whatever to it and dumps out another number, and you get those numbers out. So you shove in some numbers into oct lambda, it gives you some numbers out. And then here we're just choosing which function do we want to do. Dry lambda, now we get to go back up. And this is really messy looking. Dry lambda is a function. This section, just think of it, S is like it's the argument to the function. It's the number you're plugging in, ignore all this. And then this just says, take S, return S. So it's just a function that, like, returns the number that you gave it to. Nothing happens to it. That's why it's the dry signal, and it's called the dry lambda, or it's the dry function. Nothing happens to the signal. Oct lambda gets funky, and this is fun. So I did this because it's a relatively fun, easy effect called octave. And there's a lot of ways to do octave. It's exactly what it sounds like. So if you take your guitar and you run it through an octave pedal, the idea is basically that it takes, if your guitar is playing a lower pitch note, it transforms it and plays the note an octave up from there. So it pitches it up. And this was very popular in the early 2000s, especially with like the whammy pedal. I'm trying to think of example. Rage Against the Machine, he uses his whammy a lot. And whenever you hear it do like the crazy sounding, like it bends up by a whole octave, which I thought for a second about making that noise with my mouth, and I'm not going to, not today. That's an octave effect. Simpler, earlier octave effects, it's really cool because it's a relatively simple idea. So ideally, you've got a sine wave, right? That's like the ideal audio signal. Like if you say I'm playing an A note, like the note on a keyboard, it's an A. Nothing in the real world is as simple as that, but it would be a sine wave that is at, I don't remember which A at which octave, but it's 440 hertz. So it's a sine wave that cycles 440 times per second. With audio and a lot of signal stuff, that sine wave, it's going up and down and up and down, and I have no idea if you can see my hands or if this looks bizarre, but when it goes up, it's going into positive numbers, and when it comes down, it's going into negative numbers, which is like in math, also just the way that if you take a sine function and you graph it, that's the way it is. It's up is positive, down is negative. It's the same with basically all signals stuff. Like if you had an A440 going on an instrument cable into an amplifier, if it was a perfect signal, it would be positive voltage, then negative voltage, then positive voltage, then negative voltage. So the neat thing is, if you just take the negative parts and make them positive, you've got a wave that's effectively going twice as fast now. Now it gets a little more weird because it's not a perfect sine wave. Like a sine wave sounds like, ooh, like that's the sound of a sine wave. That's a perfect pitch. When you do that flipping, because it's not a sine wave anymore, you introduce what's called harmonics, which are complex upper frequencies that actually make it sound cooler. They give it a distortion effect. But it's how old octave pedals used to do that was they literally just use what's called a rectifier or a diode, and it only allows current to pass in one direction. And it's a whole circuit thing, but that allows them to very easily, with just one electrical component, flip the negative things positive, and you get this cool distorted octave-y sounding thing. So anyway, all of that explaining, that's why I did this, and I'm going to go through the math really quick, even though I'm going to delete this like ASAP, that's a really easy mathematical thing to do. Like if the number is negative, make it positive, and then there's a little bit more complex stuff because you don't want it all to be positive. You do always want your audio signal to go negative and positive. There's like a term for that I don't know. But a DC offset, which is a whole thing. I won't get into it. But you want to basically like recenter it, because when you flip everything up, now it's only in the positives, and you kind of want to bring it back down. And now, since you've flipped it, so let's say this was 0 to 1 and 0 to -1, you flip things up. Now your range is just between 0 and 1, so it's shorter. Is an easy way of explaining it. So when you shift it down, the whole thing is still only 1 unit tall or loud, which is also the like this direction is how loud it is. It's the volume. So now you've made it half as loud effectively. So you want to amplify it again or increase those numbers. Again, another thing that's cool about digital audio stuff, that's another one of the cool, easy things is amplification, or, it's still called amplification, but making a signal louder or quieter is multiplication. So, it makes a lot of sense, because if you have a signal that is 1 unit loud, if you want to make it twice as loud, you multiply all of the samples by 2, and now it's twice as loud. So that's another really simple thing, is that now if we actually go through the math here, oh boy, which I am rereading again for the first time. So S is the number. It's the current sample. You can think of it as the signal. And what do we even have going on here? So, okay, so this is the flipping part. So let's start kind of in the middle of this thing. If the current signal or the current sample, the current number, is less than 0, then we multiply it by -1. That's pretty much what asterisks mean in programming, is multiply. So we take S, multiply it by -1. Otherwise, it's just S, the same number. It stays positive. Then, like I said, everything is now in the range between 0 and 1. So we subtract half. Also, this is an audio processing thing. Everything is generally what's called normalized to the numbers that we're working with are plus or minus 1. And they're arbitrary or relative. Like, that doesn't tell you how loud it is in the real world when you play it back through a speaker. That just means for how loud and quiet this computer can record. It can either record at 100% loud or negative 100% loud. So all numbers are plus or minus 1. So subtracting half is the part that's going to move it down. And then this is also gnarly. So we multiply. Okay, yeah. So ignore everything after this plus. So we take that, we flipped it, then we shifted it back down. Then dry wet was how much of the unaffected signal versus the octave signal we want, which is like a taste thing. So we multiply this part, which is the affected part, it's the octave part, by dry wet. So it's going to be 75% wet. Again, wet is the effect signal, as opposed to dry, which is the unaffected signal. And then we multiply all of that by 2, and that's the part that makes it go like this. And now if we unignore the part after the plus, the 1.0 minus the dry wet, which is, this is 100%. So if you subtract 0.75, which is it's 75% wet, 25% dry. So you subtract 75 from 1, you get the 25%. That's how much dry. We multiply that by just the regular signal, because that's the dry signal. It's the unaffected thing. And add that, mix it together with the octave effect. So it's super dense, but this is the processing for an octave effect. So now, and I've been streaming for almost an hour now, just trying to explain this, which is probably a waste of mine and everyone's time. But now maybe that gives you an idea of what we're working with here. And let's see if I can get this actually happening with the old code. So let me just see if it will even build first. Quit. I have no idea if I screwed up that code. So quit hard, which means like don't delete all changes. And Rust is cool because there's just a command. It's called cargo. Sorry. Cargo is like the build system and package management system for Rust. It's very cool. So if you need like a library from somewhere else, if you do programming stuff, it's like npm or something, it'll pull the package down. So you can use it without you having to think about it and just jams it into your project, which is, I'm getting my Jack library that way. But it's cool because you can just do cargo run and it will build the whole thing and start executing it, which makes life very easy. If you don't know, for some other languages like this, it can get pretty complicated. It's going to give me a crap ton of warnings because I'm writing ugly code. Okay, and now it is theoretically running. but it's not hooked up to anything, which is a thing about Jack. Is that what we did is we made a program that tells Jack, the Linux sound system, I have some inputs and I have some outputs, and then it's up to anybody else who wants to like plug stuff into that. So now let's get gnarly. And I have a USB thumbstick plugged in over there that has, oh God, I didn't even explain this secondary part of the whole shenanigans that were happening earlier. So not only does that Dell computer does not work that I was going to use as the computer for this, that was the backup plan. I have another laptop over here that is super beefy. I may have janked it from a previous job. They have not said anything. I will give it back if they ask. But it's really beefy, and I was like, this will be the perfect thing. And then I didn't have a hard drive for it, and I tried installing the whole operating system on a USB thumb drive, and it didn't go great. But I had this whole cool thing set up where I could like build code over here, and then it would build it, shove it over to that computer, restart everything automatically. It was so cool, and then it broke, and now we're set. I have a thumb drive over there that was the thumb drive for that system, and so normally there's a couple ways with Jack. Like it's a computer program, so like you can in a program tell it, hey, connect this program's output to this program's input, and bing, bang, boom, it'll work. But then there's like, usually people use a GUI for that so that you can like visually drag, hey, take this input and connect it to that output. I'm doing this remotely, so I'm going to try and get the code that I had on that thumb drive for connecting stuff up and pull that down so I can remember how to do that without futzing around with the GUI over there, which will probably way slow us down. But I guess that's the first order of work tonight. So let me list. These are all of the like disk devices on the computer. SDA and all of those number things are the hard drive in the computer. SDB and all of those things should be the thumb drive. So let me try. I don't remember how this thing is partitioned. Mounting dev / SDB1, maybe. I should probably make a folder to mount it to. Make dir mount USB. Then sudo mount SDB1 to mount USB. Oh, and let's see if there's actually anything good in there. So what I just did was I took the partition and made it visible. Basically, is I attached it to the computer, so the computer is able to see the files on there now. If you don't know computer things, which, oh man, I'm sorry if you don't know computer things. I just put this on for background noise. My gosh. Okay, so let's CD mount USB, and there's nothing there. Cool. Sudo, that means do as the administrator, umount dev SDB1. Oh, I'm in that directory. It would be hard to unmount when I'm using it. Okay, unmounted. Let's try the second partition. Interesting. I'm just going to ignore that. Maybe this is it. Maybe this is the good one. Or maybe I just broke everything. What on earth? Oh, no. Okay, did that mount anything? Hey, cool. Okay, that's definitely the old Linux the hard drive, basically, for the old thing. So let's see if I know where anything is. CD. I think home. J Marlin. So you can see I have Jack Foolin code in there because that was the stuff that got pulled onto that laptop with that cool build system that I had that broke. But there should be somewhere in here. Let me try going up. Or no, I'm in my home directory. I had a script in here. Oh, it's jackfoolen.sh. Wow, it's right there. That this like did all the stuff where it when I pushed the code and it would get rebuilt, what it would do is it would like start up that program that just got built and then also like find the sound card, connect all the inputs automatically. Guys, it was so cool. I was so sad that it did not work out. Yeah, so this clones the code. Oh, and then it runs startup.sh from the code. That's the part that actually does the magic. Okay, whole bunch of stuff going on in here, but Jack Connect. That should be the command for like connecting inputs and outputs. And also, there's some command in here for like actually starting Jack D, the Jack daemon. Wow, messy, but this starts Jack, then does that cargo run to start the program, and this dumps it out to a log. And then it uses the command Jack Connect to connect. These are like sound card input names. So it connects system capture 1, which is like, I think that's the name for the first input on the sound card, and attaches that to Jack Foolen, Fool in 0, that program, the code that I was just showing. Each channel it makes, it just names it Fool in whatever number. And then it takes Fool out, which also, again, corresponds to one of those channels, and connects that to playback 1, which is the first output channel on the sound card. So let me see if I can make that work manually. Sometimes this whole thing doesn't even see the sound card. My laptop does not love that sound card, which is kind of annoying. So seeing if we can get that part to even work in the first place is going to be interesting. So this is, I just opened up a command line, and I don't think Jack will be running, because Jack itself, this it's a program that runs on the system and kind of coordinates all of these types of programs and their access to sound cards. So I don't remember any of this syntax. I'm probably going to have to be doing some Googling, but can I just run that? No, it's going to say you need to like specify a sound card and stuff. What's it telling me? Bunch of garbage. Yeah, and then it's telling me like I need to give it some arguments. So I need to decode what the heck I was even doing before. What if I just do Jack D dash D ALSA. ALSA is it's the actual Linux audio drivers. Again, Jack is like a service that coordinates stuff. ALSA is like the actual sound card you can kind of think of. And then I think I also need to tell it what device to use. It's that A play thing up in the upper right-hand corner is listing the devices. That's this weird complex script is having it list all the devices, finding the name of the actual sound card I want, and then telling JackD to use that sound card. So I think if I do A play -L, it'll give me a list of all the sound cards, and we'll see if the Fire Studio is even displayed, which it almost certainly is not. Yeah, it's not. These things are like in HDA Intel PCH is the onboard sound card, and I don't want to use that. So it is not detecting that thing yet, which is real annoying. Like I said, it does that. So that's not the right command. What am I thinking of? I'm looking for the command that lists, like Linux when it's running, dumps, like as things are plugged in and unplugged, it like does logging to say like, you plugged in this thing and it's over here. And I cannot remember the name of that command off the top of my head right now because I'm under pressure. I did this to myself. What is it called? Dmessage. So yeah, like all of these are like those WLP3SO. That's my wireless card. It's like saying stuff that happened on the network. Dmessage dash. How do you have it just keep listing stuff? Let's look at the documentation. There's a mode where it will just keep dumping stuff instead of like showing you everything up to this point and then quitting. God, if you're good at Linux stuff too, I hope you're having a good laugh because I am very much the at all of this stuff the jack of all trades and master of none. So yell at your screen if you need to. -W or follow. Wait for new messages. Sudo dmessage-w. Okay, so now it'll just sit there. And if I go over there, oh my God, this is going to be the first time in like an hour that I'm going to use the OBS controls. Wow, look at that. And, oh no, I set this up terribly, actually. Crap. Well, let's use, I won't set up a new thing. I'm going to walk over there. I'm going to unplug it. I'm going to replug it. I'm going to see if it says over here in the lower right-hand corner. I'm new to this. Hopefully it'll say like, you unplugged the audio card. Hopefully. I won't be able to see it, so. This is a pain. Turning it off. Unplugging it. Plug it back in. Turn it back on. Let's see if that actually said anything. Oh, Tom is here. I have not been looking at the chat. I don't know how, OBS doesn't tell me how long ago you sent that. Doesn't tell me anything. Oh, I love the way that it doesn't say anything. That is really fun. But hi, Tom. Tom is one of my coworkers, and he's a cool dude. Just for fun, just to freak myself out, I'm going to look at how many people are watching right now. Let's see if it's up to like 5. Only 4. Okay, good. Cool. Okay, so what the hell? Why is it not saying that I unplugged the sound card? You watched me do it, presumably. Let me. It's a card. 1 second. Because this laptop, like, what has FireWire anymore, right? So there is a FireWire card plugged into the laptop that the FireWire audio interface is plugged into, which may be part of the issue. Anyway, like I know this works. It just only works sometimes. Did it do anything? Did you see anything? I don't know. I didn't set up like a second monitor. Hey, okay, that looks bad, but it looks like something. Sound card registration failed. Well, that's better. Maybe the FireWire card wasn't plugged in. Okay, let me try just turning it off and on again. Anything? Okay, it didn't say it failed. That's good. I'll take that. Wait, no, I want this one. It did stuff. Good. I don't know if that's useful, but maybe we have a sound card now. So let's quit out of here. Control C. Control C. Oh no. Whew. I was worried that screwed up my whole OBS setup there for a second. I accidentally maximized the window. That would have sucked. So let me try that ALSA -L to list all the sound cards again. Nope. ALSA play. Sorry. ALSA play -L. No, I don't know what I'm doing. But you already knew that. A play. A, look at that, very bottom. Card 1, project, Fire Studio project, device 0. That's good. Okay. We're halfway there. Now I have to remember how to tell Jack to use that as the main sound card. Okay. I need to reverse engineer that stuff up on line 11 in my code again. Up where it says dbus session bus address. No hub. No hub. Jack D, -D also. -D, A play -L, which lists the sound cards. Then it uses grep to find the line with Fire Studio project in it. Then it uses sed to. Okay, so it says card 1, device 0. And that sed line that looks crazy, it says sed-E, is taking the card number, device number, and pulling them out to rewrite them as, at the very end it says HW1/1, /2, /1 is this crap, whatever it found for that crap, /2 is whatever it found for this crap. So, if I'm understanding the way I wrote this right, like the device name is HW:1, 0 would be the FirePod. Okay, so D ALSA to use the Linux ALSA drivers for audio, and then D again to specify which ALSA audio card we want to use, which is, I literally just said HW:1, 0. If I read that all correctly, should be the Fire Studio project. And also it's called Jack D, kind of important. Okay, it didn't yell at me. I think that worked. Oh, you probably can't see that in your video. Let me see if I can see it. Main room. Okay, you see, you probably, I don't know if you were paying attention, there's a little light on the front of that thing, and it turned from red to blue. That's super duper great. And it's so hard to tell in that video. It just turned red again. I just Control C'd and shut down Jack. And now I turn it back on. And blue! That's basically impossible to see, but it's working. Okay, we're getting somewhere. The real trick is also I have to run Jack in the background. Because it runs in the background. I don't know how to explain that any better. But I should be able to use, that's what is in the script, that no-hup thing. That's a Linux command that sends stuff to the background. Honup, yes, no-hup. Oh, you're not looking at my window. Now you are. No-hup, no-hup. And then, so it basically runs whatever commands after no-hup, and it backgrounds it immediately. And then we can also, let's write this to home, tilde is home, /jackd.log, and that will, because normally it would like just spew anything that's happening to the command line here. This will dump it to a file called jackd.log in case we want to look at it. And if I do that, then now we're just back on the command line, but Jack should be running. PS -E grep jack. There you go. Jack D is running in the background now. Cool. So the sound card is running. Now let's connect stuff, which is those last two lines, 19 and 20, which I think I should just be able to use as is. So jack connect system : capture 1. Oh, jack fooling isn't running. That's going to be a problem. Okay, what's the best way for me to handle this? I'm just going to do another terminal. There, that is super ugly, but why not? So I'm going to start jack up there. Then I'm going to attach jack to the sound card down there. So it should just be cargo run, right? Cargo, yes. Cargo run. All right, so it's running, but it's not connected to anything. And now, I'll be a smart person and just copy and paste. Which apparently I don't know how to do in this terminal. Nope. Okay, I'm just typing this thing, guys, because I am unprepared. Jack connect system capture 1 to jack foolin. Fool in 0. So that connects the first input on the sound card to the first input channel in the jack foolin program. Can't lock down memory. That's weird. Because I need to do it as root. Probably. I probably also need to restart jack because like I'm doing sound hardware stuff, so I probably need to be the administrator. And jack's not running as root, so it's yelling at me. So let's do that. Kill. Jack D is 5983. That's the process ID. Cool. So that's not running anymore. And I'll shut down jack for 1 too, just cause. But you can see we were like getting messages and stuff up there. It printed the jack shutdown thing. It's doing stuff. Okay. What was I doing? Right. Rerunning that whole no-hup jack thing to put jack in the background, but doing it as root because I think it needs that access. Sudo. Okay. Let's start this again. Okay, that's running. And right now it's, oh wait, no, I don't know. Don't ask me what that was. Okay, weird. It's still saying cannot lock down this memory area. This is not going great. I don't even know what that means. It's time to Google. And this is why I knew I would want to make a desktop capture one. I thought, no, you won't need that scene. You will need that scene. Unable to lock down. I hope I don't have any embarrassing tabs up. Memory area. Oh, right. So that's a whole weird thing. I'm relearning my own system here. Okay, so if you look at, what line is it? Okay, so there was this whole big fat thing that says dbus session bus address, right? You know, the real stupid thing is, should I just be running this script? Am I thinking too hard about this? Like, this script is already set up to just work. And here I am like trying to reverse engineer it, which is now striking me as incredibly stupid. Anyway, this is a whole weird thing. Dbus is a system in Linux that it's a messaging system, and it basically is a thing that allows applications to talk to each other. It was very weird on that laptop because dbus is heavily tied into X, which is the graphics system in Linux. So like dbus basically assumes X is running because dbus mostly exists so that like things in your desktop environment can talk to each other. So that like your file explorer can talk to your, I don't know, web browser, so that you can get like, I guess one of the best examples is like, if your file explorer is copying a file and it finishes, it can send a message to the desktop environment that is running the like taskbar and stuff and give you a message that says, oh, this thing finished. Even though they're separate applications, they can communicate through dbus, and that's mostly what it's used for. On that laptop that I was setting up before, that this whole script comes from, I didn't have X on there. I didn't have any graphic system at all. And I learned that you have to manually start dbus, and then it also gets really weird, which I bet money there's somewhere in here. Yes, right here. So line 6, nohup dbus-daemon. This starts dbus, which is like Jack. It's a program that runs in the background and coordinates the communication between stuff, is how it works. So you have to start that, and then it's got this print address command on there. So it's the dbus address is what it sounds like. It's if something wants to connect to the dbus system to find out what other things are out there. So if the file explorer wants to connect to the dbus bus to say, hey, is there a taskbar that I can send messages to so that I can show the user that a download is finished, it connects to that dbus address. The whole, it's usually X in the Linux graphics system is the part that coordinates creating dbus and giving everybody that address, which if you don't have the graphics system running, you have to do that manually, which is what this is. So print address basically tells it when it starts up, take whatever address you have started up at. It creates its own address when it starts up, which is just like, it's a string. It's just some name that it comes up with. And then it dumps it into this file, dbus.txt. Then later on in here, so this actually, it waits for dbus text to exist. So it waits for dbus to start up and actually make that file, is what this is, a loop that does that. Then down here, this dbus session bus address. Any application that needs to use dbus uses an environment variable, which is just it's a value that every program in a running on an operating system can access. Creates an environment variable called dbus session bus address, and the program expects that variable to be available to it and tell it what the bus address is. So normally that's set up because you started your Linux computer and the desktop came up, and when you start a program, it hands it over to that. We don't have that, so that's what this is about. It creates that variable, and then cat dbus.txt takes the address that we just dumped into that file and puts it into this variable, then runs this whole thing that starts Jack with now it knows the address. So I think that's why it's complaining. I think it's actually more the part where it was saying, let's run this again. I mean, Jack isn't running, so it's going to yell at me either way. But if I run sudo jack connect, if I run it as administrator, it says Jack server not running because it communicates to Jack using dbus. That's like the underlying way Jack figures out where anything is, and there's no dbus session bus address. Look, I'm doing all this explaining. The thing I said earlier is totally right. I should just run this script. Like, what? How stupid am I being? Yeah, let's write this as, let's copy it over to yeah, I'm just going to manually copy it over to code / Jack Foolin / startup.sh. Oh, yeah, that's what I was wondering, and it's already there, which should not surprise me. I'm just going to clear all of these out and start over again. Yeah, look, it's right there. So if I just do this, actually, I want to run this. I want to still be able to toggle that effect on and off. Here, let's make our first code change. For starters, I'm just going to have that effect always on so that I don't have to toggle it, so that we can just start this up. It'll run everything in the background, and then I can just go over there and plug some stuff in. And we should get some sound, which will be very exciting after watching this for an hour and a half. Yeah, so we'll go to Vim, we'll open the main source file, and let's see, when this all starts up, like, what does it initialize that to? What's it first set to? Does anything actually set that to anything? Let's search for effect on. So that defines it, defines a reference to it. Okay, this is it right here. It initializes it as false. So let's just go ahead and initialize that as true, so that it will be on when we start up this thing. And then let's try just running that script. Wait, let's run that script as root. Do I know my own password? It's being awfully quiet. Maybe. Today, would you like to do something? I'm sure that doesn't mean it's working. Probably something stupid. Like I do have a graphical environment over on that laptop. We're just remoted in using text. And we have been disconnected from the laptop. Okay. This is the new mystery. Did it power it? It's plugged in, right? It's on. Did it like go to sleep real hard? Hello? Okay. If I play with this locally, it says Jack is running, which is interesting. I have no idea why that disconnected. Let's try just reconnecting. That's just wild. I'm sorry, I'm just looking at my chats again now. This might, I actually have a, what is it called? A lavalier. Can you hear that? Oh, maybe Jess is in the kitchen using a kitchen utensil. I don't know. It sounds insane. It sounds like there's like a tornado above me. So hopefully that's not too bad. No, I have a lavalier mic that I broke when I was trying to set up this streaming thing in the first place on like Friday. So this is literally a phone headset that is tucked into my shirt, and it's strapped on with the little lavalier clip that I do have. So I will. I'll make sure I use this next time. It's high quality. Right, we're just gonna try reconnecting and hope it was nothing. Does it connect to the network? I like how this is how things always go for me. Is I'm not even. This isn't even like a problem with. Here, let me just do this. This isn't even like a problem with the thing that I'm trying to solve. It's just everything is. Suddenly, I can't connect to the laptop that's right over here. That is really par for the course for me. So I'm just going to see if I have a network over here. IF config. It says my Wi-Fi card doesn't exist. It shows my wired connection and my loopback interface, and that's it. So maybe let's reboot. Let's reboot. I feel like I've seen this before. This laptop has been acting really wonky. If you can't tell, literally everything, that I own computer-wise is just jank. And that's the story of my life. If I just spent some money on like a good new thing, this would be going so smoothly. But that's not what I do. Okay, it's rebooting. And I bet you $10 it's going to reboot, and it's not going to see the sound card anymore, again. Okay. Let's just give that a hot second. My God, people are still watching. That's very kind of you. Okay. So, well, I guess I can take a second here while I am waiting for this to, like, restart, which is going to take a minute. To talk about, like, bigger plans, what I'd like to do with this. God knows, I might keep at this for like another hour to see if I can get any, like, get it working again in the first place, then see if I can get like some basic looping happening. That would make me very happy. But the bigger picture too is down the road. I play with like Arduinos and stuff, and if you're not familiar with Arduinos, they're basically like, well, here's a fun way to go about thinking about it. Your microwave has like a computer in it, right? Like you go to school and they have like the talk about computers are in everything at some point. This always comes up, like it's going to be in some lecture video or something. Even your microwave has a computer. Yeah, they're a little chip called a microcontroller, and it's a very simple computer, and it's built to directly control stuff like a microwave. Like it has a pin on it that will turn stuff on or off. That's what it does. It runs a little program, and like each of these pins can connect to a switch or whatnot, and they just do like very, you might have one detects if a switch is closed or not, and that could like detect if the microwave door is closed, or if a button is pressed or not pressed. So you just have an input pin on there. And then you might have a similar pin for an output that will like send a voltage on to turn on one of the LEDs on the display. So that's unlike a CPU that you put into your desktop computer, each of the pins on that is much more purpose specific. Like it might be an address pin or a data pin that connects to your memory, or like maybe it's some kind of pin that connects to your PCI bus or something like that. And they're very specific. A microcontroller is a very dumb CPU in there, and then each of the pins is generally a it's called general purpose IO. So it can either read a simple there is voltage or there's not voltage, or set voltage or not set voltage. So that, and Arduino is it, like there's the companies that make those chips and they're made for like microwaves or things like that. Arduino became this cool thing when people were messing around with those for personal projects back in the day, because they're very cheap and you can buy them off the internet. And you can do fun things with them, like build your own little hardware. That you could build your own microwave. There you go. But so they've gotten pretty advanced. Arduino is just a company that, or an organization that makes software for making working with them easier, and makes little pre-built circuit boards with those chips on them so that it's much easier to work with. So if you don't know about Arduinos, that's what an Arduino is. The stuff I'm working with isn't Arduinos per se, but it's that kind of thing. And what I'd like to do is, you can see I'm doing like ideally a headless situation here, which means you don't have a monitor or a keyboard or a mouse connected, because I want this to be like a little appliance that I can use in my studio. And to that end, I want to use one of those microcontroller Arduino-ish boards that I play with a fair amount as a MIDI device. So like I could have, oh God, do I need to explain MIDI? Let's explain MIDI. Basically, like if you have a keyboard or something, it doesn't get used as much anymore, but like when they, in a studio in the 80s, you might find it more commonly, is like, let's say you have a keyboard and you want to like compose a keyboard part and replay it like with a drum machine. You know, like you've got a keyboard and a drum machine, you've got a synthesizer, and you want to compose a song, and you want all of these things to be playing, but it's just you. But they made this thing called MIDI, so you can basically plug all of these things together and plug them up to a computer or another similar device that can control all of them via MIDI. And so MIDI sends commands to musical instruments. It's the musical instrument digital interface, and tells them, hey, play this note, or hey, start playing the song, or whatnot. So all of this cool microcontroller hobbyist stuff that's out there, they definitely have MIDI libraries, so you can plug a thing into your computer and it shows up as a MIDI device. So you could send MIDI commands to your computer and jack this whole thing. It does audio, but it also handles MIDI stuff. I haven't messed with that at all yet. But the idea being I could like hook up some switches or some buttons to the inputs of this microcontroller, and then when a button gets pressed, it sends a MIDI command to the computer that then my program would read, and it would say, okay, start recording the loop, or start playing back the loop, or quit recording the loop, and stuff like that. So that's what I'd like to do at some point here, but we haven't even gotten this started yet, so could be years. Let's see if I can reconnect now. Nope. This might be it, guys. This might just be an episode of me explaining my intention and then being unable to do anything. Let me go look at it. It tried to boot from the USB drive. That's what our problem is. All right, let's try this again. Well, while it's restarting this time, let me actually try plugging some crap into here. So there's so much garbage around here. Right behind me is guitar amp. So, no, I'm actually not going to use that. Let me use, because I need to, we're doing all this wiring of inputs and outputs in the program, and I also still need to actually like wire something into the sound card and out of the sound card. So let's use this monitor. And that's why my area is so messy, because I just throw shit on the floor. Okay, so we're going to connect output 1 to this speaker, and I should probably give it some power. And I'll just take this guitar and plug it in to channel 1. Okay. And that's booted up. That was perfect timing. Perfect timing. For once, I lined it up. Good to see you. Thanks for tuning in at all, because this is goofy. And I don't really know why I decided to do this. But I'm having fun, I guess. I'm also trying to connect to the wrong computer. Come on. You can do it. It's thinking about it real hard, which probably means it's about to fall over if this experience has shown me anything so far. Connection timed out. Interesting. I mean, it's on. So what's your problem? And the Wi-Fi light is on this time. So no excuses. Maybe it's because my wireless settings are controlled by my desktop environment and it needs to, I don't know. I don't freaking know. Hey, thank you. That's very nice. I am pleased that I got a handful of people from my YouTube community actually popping in. That's kind of nice. So, after all of this, the issue we're having is not figuring out how to do audio programming. It's figuring out why I can't connect to my computer over the network. Thrilling. Did you decide you don't like your fixed IP address, or just generally just being an asshole? IP config, IF config. I'm on Linux. Network address is 192.168.190. Do I need to start SSH? That's the remote Linux remote connection thing. Maybe. Didn't complain about me trying. I'd say next time I'll try and be like more set up, but that's a dirty lie. You get what you get. So they both say they're connected to the network. And this one says it cannot talk to that one. Yeah, I would love to do some work with the Quadra. Actually, I have done, I was working on a little bit of programming. One of the dumb ideas that I have that I'll never do because it's insane is because the Quadra has, it's a Motorola 68K processor. That's the same kind of processor that's in a lot of stuff, but namely the Genesis, the Sega Genesis. I would love to write a virtualized Genesis emulator for the 68K Quadra, because theoretically the Quadra has a beefier style of, it's a 68020, which allows you to, it has an MMU, I think. You can have an MMU with the 020. I'm not sure if that Quadra has one. But that means that I could basically fool a Genesis ROM into thinking that it's running on a Genesis when it's actually on the Quadra. And then if the cartridge program tries to access any Genesis memory, like any of the video registers or any of the Genesis specific hardware, it would cause an exception on the processor, and then I can emulate that device and then hand back execution. So it would be running directly on the Macintosh processor. This is basically how virtualization works with a modern virtualization on a PC, but doing that with a Genesis on a Quadra. Anyway, I have ideas. There's stuff I'd like to do. I'll probably never do it. I can't even get SSH connected to my laptop, so probably will never be able to get a Genesis virtualized emulator running on a Macintosh Quadra, but it's an idea I have. I'm running out of ideas. I can't disconnect this laptop from the network to see if that will help things, because obviously I'm streaming. That thing says it's connected to the network, so what are my other thoughts? What else can I try? I can try running a wire directly over there. I can also try just, I was going to say, never mind this situation, and I'll just go use the laptop over there. But you can't see my screen. That would be a giant disappointment. So I'm trying to decide if I should just cut it off. I might just cut it off because I don't know what's going on here. The Genesis doesn't have a 68020. It has a 68,000, with the zeros at the end. It's that the extended features of the 68020 basically would allow it to pretend it's a virtualized 6800. It's wonky. Oh yeah, I'd like to do more MIDI stuff with Macs too. I actually connected a bunch of my studio stuff to an LC, and it turns out the LC is way too slow for it. It was terrible, but I'd like to do some more of that. Yeah, so let me try just restarting my network connection over on the other laptop, seeing if I can get anything working. If I can't, oh, now it's up. It just took me threatening to be done. Oh. Yeah, dude. What was that? What was that? I didn't do anything. This is my life. This is my janky equipment. Okay, we're back in. We have, let me see, I might try going to 6:30. We'll see what happens. I would also like to eat dinner and enjoy my afternoon, but I'm also having fun doing this. So, where were we? Right. Yeah, I was ready to run that script as root, right? Because I ran sudo and that's when everything just died. So let's just try doing that again. Sudo. No, I need to go to the Jack Foolen folder. CD Jack Foolen. CD code. Jack Foolen. Sudo startup.sh. And after all that, this probably still will not work for some silly reason, but let's give it a shot. My super secret password. Okay. So that's the no process found. It tries to kill any existing Jacks or Jack Foolen processors that are running. I can't remember with the way the script works if like this is running probably. I don't know if I should be waiting for it to say something else. I wrote it. I don't know. We can double check. Let me see if it's making any sound. Probably not. That's going to be a no. And I kind of would have expected a pop to come out of the speaker if it was if everything like turned on. So I'm not surprised. And the blue light's on, so that means like it's connected and it's like maybe running. Speaker's on, it's plugged in. Hey, look, some sound. Okay, so we're somewhere though. Like it's time to look at the log because that's on. Like the blue light's on, which means Jack started and connected to it. You know, the idea is to get this to the point where it's like a turnkey operation at some point, but this has been like an hour bring up. So who knows how realistic that is. But yeah, so this is supposed to dump to some logs. Control C, please stop. Here, let me just bring up the desktop and connect with another window and see if I can figure out what's going on. Oh, and it disconnected from Wi-Fi again. We're using a wired network next time we do this, firstly, let that be said. I wonder if it's, oh, that would be a pain in the butt because of the dmessage. I wonder if that's screwing with things. Me starting my own dmessage server is screwing with the desktop environment, which is controlling the Wi-Fi. It's probably not. That's kind of a conspiracy theory, but that would be fun. Let me walk over there and see if it says it doesn't have a wireless card again. Config. Yep, it doesn't have a wireless card again. That would be an issue. Okay, well, let me, here, let's, if I'm gonna go jank, I'm gonna go full jank, and I'm going to just grab this laptop and bring it over there and point a webcam at the other computer. Are you with me on this idea? Okay, let me restart this webcam. Room cam. Because I had to unplug it. Hey, okay, there we go. Let me give you some nausea. It'd be cool if I had a stream that didn't have, or a setup that didn't have the code window at all, because I'm not going to use that anymore. There's the laptop. Okay, how now am I going to set this up so that you can see the screen and I can actually work? What if, here's another idea. Take this laptop, point it at that laptop. I'm sure you can't see anything. No. Yes. Okay. And you can see nothing. Like this one would work better. Maybe. Well, screw it. You're just going to have to enjoy not being able to read anything. I don't think there's any way to get that in focus. But it is what it is. This is what we're doing now. Okay, so I'm going to pull up Jack with the GUI. Firstly, let me manually stop any sudo kill all Jack D sudo kill all Jack Foolin. Cool. Then we listen, and I'm going to start up the GUI Jack thing that I was saying we weren't going to use because we were going to do this remote because no good reason. QJack control. Hello. QJack control. Okay, so now Jack is running, as easy as that. But it is using my onboard sound card, and I want to switch it to the Fire Studio project. Okay. Yes, that's good. Stop, start. And now, cool. Now there's a bajillion. There are 10, I guess, not a bajillion, just 10. Inputs and outputs. And we're going to want to turn these way down now because I cranked this up to see if it was working. And I do not want to blow your ears out. Okay, so I'm just going to connect capture 1 to playback 1. And watch it still not make any noise. Honestly, that's weird. Like, those are directly connected. This should be making sound. Nothing. Okay. Am I missing something really stupid? Probably. that should just be the first channel going out to the first channel. Wait. Damn it. You have to like hit go. I mean, this should still be making some sound though. I mean, I'm not even running my program at this point. I'm not doing, I'm just trying to connect the input to the output. It's the second you point a camera at something, it all goes to hell. I don't know, let's try this different one that's the same thing. Start. Started. Welp, this has clearly spun down a lot in energy in the last several minutes. So I'm going to. The problem is I'm using Linux instead of Eric's. Also probably true. Aaron, what? How long have you even been watching? You managed to watch all of the it not working part. So here's what I'm going to say. The energy has super spun down on this because like I'm doing everything the right way now just to get an input connected to an output, and it's not doing anything. So let's call this a trial in streaming at all. And the fact that I have been able to actually set up OBS and people seem to be able to hear me and interact with me, and that works. That's a win in my book. And we will try again maybe next weekend, and I will this weekend. Like I went on a weekend trip on Friday, so I had an hour to reset this up, at which point everything went sideways. So let's try this again next weekend, and I will like try and do a day before of setup so that like we can actually do work instead of just trying to figure out why we can't get started. And we'll try again. But for now, I'm going to call it because I can't get the input to go to the output without even my software running. And that seems like an issue. So yeah, I'm done. But that is actually that is there's two of them, and they are two CXs or two CIs. They don't work. They need to be recapped. I got those in a big haul of Mac stuff years ago, and I've been meaning to recap them for a long time. The Quadra 700 is actually on the other side of the basement. Maybe I'll do a live stream about that someday. But thank you, Aaron. I would if I could. I can't. I won't. I don't want to. That's what it is. I don't. But next weekend. Okay, that's. I'm done. Instead of just rambling. Thank you everyone for checking it out. However many 3 or 4 of you are still watching the stream, and I will see you next weekend. If you maybe I'll try and put a thing in the description or a comment. The last thing I'll say is my plan is I'm trying to actually like get back to Twitter and make Twitter my hub of things. So I will drop my Twitter stuff in the somewhere attached to this video, so that you can be notified of when I'm going to try and do this again and what progress I make, and if I figure out what the heck is going on here, because I guarantee you it's something simple and stupid. But next time I will be actually properly set up and we will try again. Okay,